Hi, I'm Gabe.
And I'm Aria. And for Maker's Faire, we built an electromagnetic launcher.
Hi, so what is an electromagnetic launcher? Basically, think of it as a Nerf gun that operates on electricity running through coils. Our goal was to have it shoot at around 30 meters per second, which is like on the fast range of Nerf guns. And our project goes under the categories for engineering and math.
So the process behind this is pretty long. First was figuring out the math for this project so we could find what materials to buy. This involved a lot of research and perusing data sheets, then came actually tracking down the right materials, which was a whole other problem. There were a lot of materials that went into this project, from the flash circuit we used for the charge, to the logic gate we used to make sure that nothing would blow up, to the in and out straw we used as the tube. Next was actually building this project, and that took a lot of effort and had an incredible amount of setbacks.
The main challenge behind this project was about what you would expect. Everything kept working until it very suddenly and abruptly didn't work at the most inconvenient times. So we kept troubleshooting, we kept adapting, and we kept frying things intermittently. It's all part of the learning process. And we're still working on it now, but we're definitely making progress in the right direction.
Yeah. So you might be asking, what exactly was the math behind this? We discussed this a little bit. First of all, we used RLC differential equations to model the flyback voltages and the LC oscillations. We also used logic gates to find how to model how each button should work. So for instance, if you were to press the shoot button, but the capacitors weren't ready, then everything would go crazy. So therefore, having that button check if everything is ready before actually firing was an important bit of the project that took logic gates to figure out. LC resonance circuits were used to measure inductance only if we knew the capacitance. We also learned about a type of oscillator that calculated things similar to equations used for predator and prey systems, which we found very interesting. This project was also a bunch of small, seemingly unrelated equations that all ended up interconnecting. So what we have here is the equation that we use to find the mass of the projectiles and the energy and capacitance we would need to support the speed we want it to go at. So we knew we were going to use a soft iron projectile, so we found the density for that. We found the size we wanted, and from there we calculated the mass. We decided on an arbitrary 30 meters per second for the speed because we thought that was somewhat fast. And from there we calculated the kinetic energy, which is 1/2 of the mass times velocity squared, which amounted to 5.6 joules for each projectile. However, electromagnetic launchers are not that efficient. In fact, they're about 1 to 5% efficient. So therefore, we knew that we'd need about 112 joules to actually be stored electrically at absolute minimum. 330 volts we decided for wiggle room. So to calculate the capacitance, the equation we used was that energy equals 1/2 the capacitance times voltage squared. So using our 330 volts, we found the capacitance was 0.002 farads, or in other words, 2,000 microfarads, which is a lot.
Okay, so in conclusion, I learned that charging a flash capacitor is actually insanely more complicated than I have ever imagined, and it involves a lot of very, very fast, very, very small, and very, very abrupt changes in voltage that are quite violent on electrical components, to say the least.
I hadn't had that much experience with engineering before this, so learning how to do things like solder was really fun. And yeah, also learning about flash chargers was really cool. If we were to do this again, we would probably have found a more convenient way to do a lot of these components and bits and bobs of this project, because we also found ourselves oftentimes replacing perfectly good parts. Though we did get a demo working, the unpredictableness and volatility of this project means that we did not, unfortunately, get it on video. So we don't have anything to show for the demo section of this project. However, this doesn't mean that we aren't so proud of the hours and weeks that we've put into this project. We have learned so much and we've come so far. Thank you for watching.